Yeah. Good morning, everyone. Hello, people connected remotely. This is the past Computation Elements working group session. Not well. So we are Friday already. You should all be aware that there are IPR rules within the IETF. So everything that you may say within this room or over the mailing list are considered as contribution. There are rules you should abide for. So make sure you are aware of them and that you're compliant. So other not wells related to the behavior of people, please make sure that you respect other people, even in case of disagreements. In case of abuse, there are some people in the IETF who may help trying to resolve the situations. So this is a mixed meeting. We have people in the room, some people connected remotely. So make sure that you respect the processes related to the queues and use the mics when you want to say something to the group. And this is recorded as well. As usual, we have a minute taker, so thank you, Andrew, for taking care of them. If you want to give Andrew a hand, there is a shared link there, so you may join either to help or to correct misunderstanding or missing pieces in case you said something that wasn't correctly reflected in the minutes. So whether you're in the room or not, remember that you're supposed to join mythical queues from the app, and we'll then give the floor to each one with respect to the order in the queue. The reminders about the list, we feel that sometimes too many things are happening out of the list. We are involved as chairs on many private discussion. Many of them should happen to the mailing list, so sometimes we send explicit reminder. This is one of them. And also at the various steps of the working group process, please make sure that you are trying to get involved, especially you have a pending adoption call in the mailing list. So we are aware that starting a call close to IETF deadlines wasn't the best way to make sure people were actively reading the list. But in case you want to give feedback about the adoption of the PCE point-to-multipoint, it's in progress, and we'll try to take a decision within a close future. The agenda, so we have a very tight agenda. In case someone wants to bash anything, this is the last chance. Otherwise, we move on. And working group status. So the work is progressing quite well within the PC working group, I feel. We have 2 new RFCs published since the previous IETF meeting. We have 4 in the RFC editor queues. And one with the AD currently. So this is quite sign that we are moving the work forward to publish it. So thanks for people involved. We know that even if a draft has passed working group last call, there are many steps behind. So make sure that when you're a contributor or author that you make them progress as fast as possible to make sure it gets published in a reasonable deadline time frame. We have some draft with early code point allocation. Some are renewed regularly, so we have the deadlines here. One of them was renewed pretty recently. So make sure, especially in case you have early code point allocation, that your document will progress fast enough so as we don't have to renew them more than 2 times. Otherwise, the decision is raised one level up within the IESG, and there is no guarantee that you will keep your code points. So try to rush a bit the document once you have requested some early code points. Thank you. We have some new errata coming regularly. Some of them are listed here. Most of them are minor, but it's good to track them and make sure that people have correct understanding about the corrected text. I see Ketan joining in the queue. Oh, okay. So, status of the working groups, ideas.
Just a quick note on the code points expiration. Even if they do expire and they are not renewed by the ISG, like approved by the ISG, they still will remain in the registry in an expired state until the chairs and the working group decide that they need to be deprecated or returned or whatever. So if it happens that there are like too many instances that are going to ISG, then I would be inclined to not take them anymore to the ISG. So they will stay in expired state. Just wanted to communicate that with the working group. So it doesn't make sense to again and again ask the ISG for approval. Like few times is fine, but just
Thanks for a reminder.
Yes, thanks. Yeah, so I'll quickly go over some of the drafts update. Since we have a tight agenda, I'll try to be quick. We have 2 documents which are post working group last call. One is the state sync. This is pending on me. The documents, the authors have made an update. Now the Shepherd review and the write up is pending. This is on top of my queue. So expect a response very soon. We have FlexGrid. This document is expired, and I think we also need to we have an issue here that one of the authors is retired and now unable to reach. So we are expecting authors to respond on what is the next step. One possibility could be, provided that the author has not provided text, they can be moved to acknowledgement. So come and discuss with us what's the next step. We have sent reminders, but we have not received a response on this. These are is our working group last call queue. We have circuit style, which seems to be ready, bidirectional path, P2MP policy, and PCCC SR. So these are the set of documents that we will be last calling. As a reminder, we need implementation section and the manageability consideration section in our documents. We have been doing that from much early on compared to other since this topic, you must have heard of adding operational consideration in all RFCs, but PCEP already had that, and we are tracking that as well. So please take that into consideration. Write these sections early on rather than at the end. Again, our queue, here you will see that many things are pending. We try to highlight from chair's point of view what are the next step. Please take this into consideration and make an update. These are the documents which are almost ready for working group last call, which we are maintaining it here. If you have any thoughts about these working group documents, please use the list and let's have a discussion there. Let me directly now jump to the working group adoption part. As we said, there is one document which is still in adoption call. This is your last chance to give a response. Please do that. And otherwise, these is the current adoption queue that we are maintaining. Is there any comments on any of the working group documents? Otherwise, let's go to our agenda as well. Any comments from any of the authors? No. Okay, final point. There was this discussion on the mailing list saying that PCEP has lots of extensions. It has a long history. It's been around. It has been developed for different cases. And for a new person coming into PCE working group, there was this idea that figuring everything out at the data tracker is not always easy. So can we do something to track all our features and our documents in a better way? I made one proposal that we could do it via maintaining a mind map, which could be done in a manual way. Or also I figured out via GitHub, there is a way to use Mermaid, and where you can maintain these mind map, which other people can also edit collaboratively. I have discussed this with some of the working group participants, but if you have ideas on how to do it and whether we should do it, uh, this is still early work. It's on our GitHub, but feel free to reach out. And I think we should always make it easier for new folks to find our work and do it. So any help in that is, I'm sure, will be appreciated. And if there are any volunteers to help me on this, please feel free to reach out. And that's it. Any questions? Any comments? Do you want me to? No, first remove the one, then it's easier. Clicker. Yes. Yes. And then go for this one. Yes. Yes. Samuel?
Hi all. My name is Samuel Sidra from Cisco, and I will hold 3 different presentations today. So this one is about draft describing SR algorithm in PCEP, and I'll be presenting it on behalf of authors of the draft. I'm not sure if I have control.
Samuel. No, not to the clicker, to Samuel. Just 1 second, Samuel.
Yeah, sure.
This one plus one. Yes. Yeah. Go ahead now.
Okay, I have it now. Thank you. So our primary goal was to align PC computation with the underlying RGP flex algorithms. By doing so, we can compute paths which are congruent with how the RGP behaves in the network. So the benefits are significant, and it helps to reduce the number of seeds required in the segment list. And it also simplifies the deployment and management of flexible algorithm paths, especially in multi-domain scenarios. Our proposal covers both traditional SPF and strict SPF algos, as well as the flexible algorithms, so the range of 128 to 255. And it is then allowing us to, for example, restrict the path computation to strict SPF seeds only, or to any specific algo. So the route was presented on IETF 120, and we have made several updates based on valuable feedback. Thanks a lot, Drew and Ketan. The feedback was really great. So the document looks much better now. One significant simplification is the removal of the dedicated F flag from the SR algorithm TLV, or from the SR algorithm constraint. I'll describe why that was possible next slide. Regarding the encoding of SR of the algorithm field in YAROW and RRO, for the standard SR YAROW subobject, we introduce new subobject extension block. For the SRE6 YAROW subobject, we optimized the placement, and we moved it into existing result field. So the subobject's length isn't increased. One significant simplification is the removal of the dedicated F flag from the SR algorithm constraint. To clarify the SR algorithm constraint and seed filtering. So after confirmation in mailing list, we figured out that the seed filtering is not required anymore for the SR algorithm values in the range from 0 to 127. And flexible algorithm path computation, on the other hand, is using the range of 128 to 255. So those are two dedicated ranges, and that simplifies the processing. So we don't need dedicated flag, since each range has its own dedicated type of processing, which was not possible before because we supported the seed filtering for the flex algo range as well. Now, for the context of extending the SR subobject, so RFC 8664, which define the SR subobject, specify explicit subobject length for all the flag combinations. So there are multiple flags, and for each flag combination, there is a statement indicating what's the expected size. So we can see some examples at the beginning. So there's even simple extension of SR subobject with new SR algorithm field, which has single byte, required an update to the RFC to specify updated statements, all statements to indicate what is supposed to be the length for all the combinations again. So we try to update it. I'll describe it in the next slide, but the diagram which is displayed here is the original structure of the SR ERO subobject which we used originally in the draft. Now for the proposed solution, so the proposed solution is designed to address the problem which I described in previous slide. So the complexity which is required to update the SRERO subobject or extend it for any future document as well. So we introduced a subobject extension block within the SRERO subobject. This block has variable length, and it is always aligned to multiple. That length is aligned to multiple of 4 bytes, which provides the flexibility for future extensions as well. Within this extension block, we place our new algorithm field, so it is in same location as it was before. We just, let's say, wrapped it into subobject extension block, and the existing reserved field, which is often used as a padding, may be reused by future documents. So even if some new future document will require, I don't know, 1 or 2 bytes, it can still fit into same 4 bytes which are already allocated for as an algorithm for. It is important to note that the length of the variable block is computed by the overall subobject length. So for future extensions, they introducing new fields, which all of them will require new capability exchange and also some dedicated flag in the flag field of the SRERO subobject. So any future new document will need to define the exact position of that new extension as well. So keep it in mind, because that's the way how we are extending the SRERO subject will impact the future extensions as well. The key aspect is really the full backward compatibility with existing implementations which are done for the Hidalgo draft already. So those are the backward compatibility is maintained. We are not breaking it, and it is still future compatible as well. So the next steps, any comments, discussion is welcome. Please make sure that you understand how the SRERO subobject is extended and what's the impact for the future. And we will update the draft based on what I described so far. It is not describing the rules for future documents. So we have the plan to update the draft based on that. Thanks a lot. Any questions? Any comments?
A reminder to the working group, this is a document which has already finished working group last call. These are the comments being handled after the AD review. And again, when I was updating the Shepherd report, it's as a working group, we need to make sure that whatever changes are being done afterwards, there is still consensus. That's why it's important that please pay attention. That's why we asked Samuel to present to the working group as well. So any feedback, any concern, please raise them now. Otherwise, no, going fine. Okay, anyway, Samuel will post the update. Samuel, just let's keep the push going, make an update, give some time for people to feedback, and then we can discuss among the ADs, Shepherd, and us what's the next step. Thank you.
I agreed on that part. I'm working on the update already, so it should be hopefully posted during next week.
Thank you so much. You also are presenting the next one. Go ahead.
Yeah, thank you. So my name hasn't changed, so still Samuel Sidera from Cisco. This presentation is about binding seed extensions in PCEP, and I'll be presenting it on behalf of authors. So let's start by looking into existing behavior for binding labels or binding seeds in PCEP, as defined in RFC 9604. So currently, binding label allocation can be performed by either PCC or PCE. And the important point here is that the role of the PCEP peer specifying the label to be allocated doesn't have to be aligned with the peer which is doing the allocation. So, for example, the PC might specify the label value and the PCC performs the actual allocation. It can be reversed as well. A key aspect of the current behavior is that there is, if there is allocation failure, so if the binding seed is, for example, used already, or if the label value is used already for something else, the PCEP error message must be sent and the entire PCEP message must be rejected. So that's important, and that's the aspect that we are trying to change. As our policy architecture RFC, we also have the dynamic fallback mechanism described. This mechanism provides an alternative to fallback to dynamic binding seed if specified or if explicitly specified binding seed is not available. Such approach currently requires the reporting of two different binding seed TLVs to manage that fallback, and that was not supported in PISA before. So now for the proposed solution or proposed extension, our draft introduces three new flags within the binding TLV to enhance the flexibility and handling of the binding seed allocation. So first is the A flag. When this flag is used, the TLV instance with the originally requested binding value will have the A flag cleared, and TLV instance with the actually allocated binding value will have the flag set. So there will be two instances of the TLV, one indicating the requested label and other one indicating the one which was really allocated. Then the F flag. So the requested binding value, if the requested binding value is not available, the PCEP must attempt to allocate the new binding value from its dynamic range. So this is really allowing the fallback to dynamically allocate it. So the behavior which is described in as a policy architecture. And finally, we have the D flag. If the D flag is set, the requested binding value and the requested binding value is not available, the PCC must instantiate the LSP. So it will not reject the entire message. It will create the LSP, but it will keep it in down state. So the PCC can still try or may do some retries, can try to allocate that label again, and if the label will be available again, we can bring up the LSP after that. So this allows us to create the LSP and but keep all the services down and basically pending for the resolution of that conflict. And one important note: F and D flags are mutually exclusive. Plus, we have the capability to indicate the support for all T flags. So for the next step, so this is the first version of this draft, so 0.0. So any feedback is welcome. Yeah. If there are any comments or any questions, feel free to ask. we will continue with refining and with adding more details to the draft.
Are there any comments for Samuel? Boris?
Boris Hasanov, MWS. Sam, could you please clarify the point of having D flag? So why do we need instantiate LSP while it will be in down state?
So it's for solving the temporary conflict. So let's say that you will create the LSP, it will be in down state, but if that conflict will be solved later, then the PCC may do the retries. So you will keep the LSP in down state. Let's say it is conflicting with maybe you are replacing, let's say, one police with the other one, and both of them are using same binding seed, and the previous one was maybe not deleted yet. It will be deleted, let's say, 1 minute later. You will, and as soon as it is deleted, the new one can pick up the original binding seed again, and it can go up. So for a short period of time, it will be down, but then when the conflict will be resolved, it will go up again.
Okay, thanks.
Thanks for the question.
My suggestion, Samuel, would be that I think in the document, maybe an example could be added to explain how these flags are being used, because otherwise the text is not as super clear. And like Boris, I was also wondering the same thing. And the best thing would be to add an example in which all these different flag combinations play a role.
Yep, thanks a lot for the suggestion. So I plan to add the motivation section where I can also describe, let's say, the added value of those flags.
Thanks.
Thank you.
Zafar?
Hi, my name is Zafar Ali from Cisco Systems. I'm presenting this on behalf of Andrew, Diego, and Samuel. So just a little bit of the history before we get into the details, why this draft was written. So the last IETF, Andrew and Diego, who are here, approached me and they say that you're working on the seed list optimization, which is the SRv6 use case next on the agenda. We noticed that there is an MSD inefficiency in the way that the NRSC is very strict in the wording, that when the first seed of whether SRv6 or SRMPLS policy is a UA, that UA never goes on the packet. That's the first header node that is steering, so it doesn't need to go on the packet. First header node understood what is the outgoing interface, it don't go in the packet. So there is that inefficiency. So initial thought was that we're just going to upload, like put this detail that is here in this draft into the existing seed list optimization draft. That when we dig further, then it turned out that, I mean, this is applicable to both SRVCs and SRMPLS, where the seed list optimization that is next on the agenda is SRVC specific. So we thought that, no, let's keep it separate to avoid any kind of confusion. So giving the history, so I think what is important is to highlight the second bullet, which is from RFC 8664. It mandates that when a SR-capable PSAP session is established with a non-zero MSD value, the corresponding PCE must not send SR path with a number of seed that exceed the MSD value. But here there is no consideration in terms of the first seed being UA because it never goes in the packet. So it's not chewing up from the MSD space. So, and that's really what we try to solve in this case. So summary of changes, a pretty simple draft. So it says specify a procedure for this optimization that outline. In here, PC can communicate with the, or can consider first UA and then go on the rest of the encoding that goes in the packet in the MSD consideration. And like I mentioned, this apply for SRMPLS and SRV6. And we absolutely made sure that the procedure is backward compatible with the 8664. So it's not breaking anything that is existing. So for this, what we did is just to make sure the backward compatibility, because the most important part is that backward compatibility and the understanding that the PCE is capable. PCE can do it on I mean, if you don't have a backward compatibility issue, then PCE can do it without any signaling, but because the RFC is very strict, what we did is that we define a flag in SR PCE capability for SRMPLS generic and SRV6 PCE capability for SRV6 use case. When it's set to 1, it's really mean that yes, there is an understanding that the PCE is not exactly following the restriction that are there in the RFC. So for that matter, basically just updated that when this handshake between in the PC peers that the board entity understand, then PCE can actually consider MSD value or ignore the UA in considering the MSD calculation for the device and install the SID as usual. It doesn't change anything else, but I think the most important part was the backward compatibility, making sure that this is not breaking 9603. I think it's a simple enough change. Then would like to ask working group for adoption and also seeking feedback.
Are there any comments? Andrew?
Andrew Stone, Nokia. I just want to echo the same thing and just kind of re-emphasize to the working group. Somebody I was chatting with last night actually put it well. We just found cash in our pocket, right? We're managing to get one extra SID out of here, and that's really quite useful. So, and the change is relatively minor, and at the end of the day, it's a validation on an array in a lot of cases. So, yeah, definitely support working group adoption. Thanks.
Just one query. Did we do a survey of like vendors? Is everybody implementing it in this way? Is there any confusion in the industry that whether when you are doing the MSD calculation, because it's not very explicit, I'm just saying that are there confusion? That's why this flag is being done, or are there other ways for us to fix this?
The main thing is like the text that basically says the length, or actually, yeah, the number of SIDs. It doesn't evaluate what type of SIDs. And so purely based off of the raw number of SIDs, it doesn't matter what type of SIDs they are. And in this case, if the top SID's adjacency, it's actually irrelevant from an MSD point of view. So if somebody reads the text and follows it literally, they should be validating the number of SIDs without.
And my question is, what are the current implementations doing? Are they including it or not?
Sorry, including
the adjacency SID in this calculation or not?
I can say Nokia's implementation uses adjacency SIDs for various use cases, and so we can basically get one extra SID out of this if the top one's an adjacency.
My confusion basically is because this text doesn't explicitly say, could it be about at the time of imposition, what is the SID stack, or at the time of calculation? So my only thing is, I understand this is a problem we should clarify. My worry is, should we do it via adding a flag and doing it, or just an updating an RFC and saying, look, the right thing to do is not to include. Now we are updating RFC 8664 and clarifying this.
The flag's needed because you might have PCCs in the network that have also a validation check on their side. And so lots of PCC implementations also do a validation to make sure that PCE is not sending them bad data. So if PCE decides to send, for example, an ERO that exceeds number of SIDs exceeding the MSD value, I would expect an implementation today to reject that because the RFC says don't do that. And so we need that flag to basically make it backwards compatible.
So my suggestion is, like, let's have one discussion on the list. on this topic. We know people in the room, get that feedback, what people are actually doing. I'm just worried that adding a flag would mean, like, when would I not set it? That's the part which feels very weird to me. Like, I have added this flag saying that I want to, like, you must include adjacency said in the MSD calculation. That feels very off.
No, it's actually just saying that the implementation is aware that the top
That
SID
part with backward compatibility, I totally agree. I was just thinking it like the end state that we reach, does it make sense? Or we could just do the right thing by just updating the RFC and saying that, like, look, this is what must have happened.
I could say from our implementation, if I was to go change, for example, the PC to understand this, and I signal that down to our PCCs, the RPCCs would reject it because the RFC very clearly says you cannot exceed the number of SIDs. So we need something to say that this device actually understands that we're loosening the language under a very specific scenario, basically. So sorry, Zafar, I think you wanted that.
I think I second Andrew on this. So you have two questions. Question number one is that does it say that is it really PCC or is PCE? So if you read it, and I put it in the front of us, the text from RFC is that PCE must not send SRT path with a number of SID exceeding that MSDLE. So it's about the path that is sent. Is not about that encapsulation that actual packet would be like this, but is about the ERO. So I think it's very clear that that's an issue. At least from top of my head, the PCE side of us or our implementation does follow this rule. So it does not differentiate if the first one is UA, then I'm going to just pack another SID. And I agree with Andrew that this is important because MSD is a very important constraint, especially in the SRMPLS case. So I think it's very important. Whether this.
Yao from ZT. So my question is about the last bullet. So is it, so when an adjacent SID is the first SID in the SID list, so the top adjacent SID is not imposed on the package. So is it a must or is it implementation specific?
I think is a must because if you put the top SID as being a local agency, the packet will not go because somebody will look at it and is not local to the neighbor that will receive it. So your packet will get dropped. So I don't see any way anybody can implement. So this is a must in any implementation. You cannot carry it because this is just an indicator that what is your outgoing interface. Once you have resolved your outgoing interface, nobody else in the path is going to look at that packet and forward based on that. It's your local agency. You're supposed to take it off, so it's a must.
So maybe could it be more generic case? Because when the first, so even when the first is node SID, we have the reduced mode. So the first node SID would not be put in the SID list as well. So would you consider, so is it same consideration for the reduced mode if the first SID is not SID?
So I think reduced mode is slightly different. It's SRVC specific. A reduced mode really means that when you have a DA, the SID is in the DA, you don't have to copy this in SRH. That's reduced mode. So that's for the compression efficiency purposes. And if your first SID is not UN, as a AUA, like is a UN, you must carry it because you have to take packet to that. So, so I don't think any kind of overlap with the reduced mode.
Okay, thank you.
Thank you.
Thanks, Zafar. I suggest let's discuss more on the list on this part.
Okay.
Thank you.
Thank you. How much time I have?
You have time.
Okay.
5 minutes.
Okay, thank you. Okay, so this is a draft that we presented also in spring yesterday. So we have And so just a bit of a history. I am actually presenting it on behalf of my co-authors here, and thanks to them. Okay, so like we discussed, just to reiterate in spring yesterday, in SRV6, this is SRV6 specific. This is nothing to do with SRPLS, but in SRV6 case, because the locator of a service or a locator of binding set or some traffic that is getting steered over the SRV6 policy takes the policy to the endpoint. And the endpoint node state is also in the SID list of that policy. Then the endpoint has to deal with two back-to-back SIDs because it will process the node SID, which is come from the policy, and it will also process the service SID, which is on top. So carrying these back-to-back SID is inefficient, and then again MSD consideration point of view, and also so compression efficiency as well as MTU consideration. So and the other point is that it is not all cases that you can always exclude the endpoint node SID, and there are use cases for that as well. So it depends on what kind of traffic is so steady. So just a little bit of the draft history. So we have presented this draft in IETF 121 as draft early PCE SRVC policy setlist optimization. Then there was another draft, which is draft lane PCE SRVC segment list optimization. That was also here. So we met and we agreed to merge the draft. And then the draft that is in front of you today is the merged draft that was done after IETF 121. In IETF 122, we presented this the same draft that is in front of you with the encoding that is today is in the current version, so no changes to encoding. But the flag numbering, there was a comment that we must try to make the flag consistent across PCE changes, BGPTE changes, BGPLS changes, because we were using different alphabets. So we went back and so current changes that are in front of you that we are presenting only includes change from I flag to ENS flag. There is something, but just want to highlight that there is no change in encoding in this version from version 0. The other comment was that adding the MSD consideration section, and that was added. And what was also highlighted, because we have 3 different documents, so for coordination and the feedback for the chairs was to have a spring document, which is the placeholder for the high level, and glues these 3 changes together. So we did that, and we presented this to spring yesterday. Summary of changes, like I mentioned, the only change that is there in this version is the naming of that bit that is defined. So from I flag to ENS flag, and the consistency, we added inclusion of the PCC initiated. So this is applicable both for PCE initiated LSP and also for PCC initiated LSPs. There was no usage change or container change except the flag renaming in this version. So we feel that we've been and we've been talking and collaborating a lot of people in this and discussion. So there is a general sense that this encoding is stable, and we have presented it multiple times. So and then we have also done the spring, which will progress as well. So we think that the draft is ready for adoption, and if you can consider it as a candidate for adoption and put in the queue, so that we can move further on this work.
Questions?
Thank you.
No questions? Chairs will discuss and we'll get back to you on the adoption thing. But I
Thank
think
you.
thanks for making progress.
Thank you very much. Thank you.
Andrew. Number 2, 3.1.
Hello, everybody. Oh, this is really low. I'm here to talk about the operational clarifications on behalf of the co-authors. So just a reminder, this was recently adopted. It's a pretty old draft that's just kind of been floating around and was pulled in, I guess it was last session or just before that. The main thing is it provides additional clarification just on how to do PCE, PCEP implementations. Basically during interop testing, there's different interpretations of some of the language. And so this document just tries to emphasize how those words or those sentences should be kind of interpreted for actual implementation. So the changes, thanks again to Adrian and Tom. So the main changes, the core content of the draft didn't really change so much, but there was a lot of editorial updates. So for example, the more we language, and very important because it is an informational document, there is no more requirements terminology in there. So the sentences have basically been recooked to kind of confirm that, it's just explaining things. It's not actually saying you must do this. It's just a re-explanation of the topics. One of the things that was being discussed in the document was this term LSPDB and how you might operate on the LSPDB. There were concerns that some of that language was very implementation specific or how one might implement it as opposed to conceptually what it is. So in the draft, we basically decided to kind of split that apart. So there's this concept of a PC report LSPDB, which basically just says there's this logical thing that's dealing with your PCEP messages, especially from a PC report perspective, compared to an extended LSPDB, which is you can contain whatever you want in it, right? And so the draft doesn't actually talk about how to manage intended state or telemetry because that's kind of an implementation detail. So we just wanted to make sure that anytime you are working on a PC report, that's being done consistently. And yeah, just again, more just editorial updates. There is a topic Adrian raised, which is it's a really good question, and I'm opening up here for the group. Maybe we can have a quick chat about it after this presentation, which is in the document it discusses PC overload. And so right now the text says keep sending PC reports, right? Even if the PC signals that it's overload, send reports just like usual. And so Adrian raised a concern about, well, should it still be doing that because it's overloaded, right? And PC reports can also contribute to being overloaded. So you see, it's just Adrian had suggested maybe some kind of thresholding or throttling, checking for significance of change, things of that nature. So that's a question. Should we be doing that? And then I threw it in here just to say as an alternative, which I also don't want and don't think most people want, is to stop sending reports. So I'll just skip this and maybe we can come back to it. And so next step, there's also some additional comments and gaps in the document, and basically just going to keep refining it as time goes on. So yeah, so I'm going to come back to this question. Does anybody have any thoughts or input on this?
Samuel, go ahead.
Yeah, at least from my point of view, if we will stop sending the reports, then the PC will go out of sync. Right? It will not hold the complete state of for all the LSPs. It can even work with some outdated state of those LSPs. So I personally also don't pay for the C option. So either some throttling needs to be done on the PC side, so PC can drop what it thinks that it is maybe not important, or it can decide on its own about what is important, what is not.
Yep, totally agree.
Boris Kassanov, I would vote for B option. Keep sending what we throttle.
I think at least the question for me would be what defines significance or what defines a certain time interval.
It will add additional complexity.
Yeah, it's from an implementation point of view, it's that itself is additional load on the PCC, which, okay, fine, it's PC that's overloaded, but even having some kind of consistent rule set of, when is it significant?
Okay, yeah, either A or B,
okay,
but not C. Definitely.
Does anybody feel strongly for doing B? Obviously, your opinion is B. Is there strong opinion to do B, or do we think we can keep it as A, or maybe we'll just have to let that linger, I guess. But
Samuel, you're back.
Yeah, I'm back. Maybe one more option is to even close the session, because if we will stop processing the reports, then maybe closing the session and opening it when the overload will be overcome. Then the releasing can be done with new session, and basically we will make sure that PC is working with the updated state. Because if we will drop any reports, that complexity to decide which reports can be dropped may be still, yeah, it may be complex. And basically we will keep processing all of them, as mentioned already. That will probably not work. So we will close the session completely, so the PC can selectively close some sessions. If, for example, the overload is happening because of, I don't know, too many sessions, it can decide to close some of them and basically open them after some time when it will be more stable again.
so if I just reiterate what I heard, you would suggest PC can kill some sessions until it's ready to bring those back again and then sync in.
Yeah,
Okay.
exactly. And it can do it selectively, so it does not have to do. So if the overload is happening because of 2,000 sessions open, it can kill, let's say, 100 of them and continue processing remaining 1,900. So
Ketan Talaulikar, as a individual working group member, this kind of a scenario is there in BGP already. Perhaps consider some of the lessons learned from there on how to handle this, and how a lot of this is in implementations, if I may share that. So yeah, instead of trying to re-engineer things.
As with all things, just look towards BGP. Yeah. No, thanks for that. Okay. Unless there's any other questions, I guess maybe we'll go to the next one.
I have one question. Let me just add myself in the queue. Can you go back to the first slide? Yeah, this extended LSPDB, I searched, you are using it 3 times in the document. Everywhere else is just PC report LSPDB. I am currently not seeing the advantage of unnecessarily calling it out. If there is a reason, maybe you have some updates pending or something why you wanted to differentiate these two things.
The main thing that we were trying to capture was that intended state, right? Because a lot of PC implementations have an intended state, and we were basically trying to say that your PC reports, the way in which you handle that and you modify that, how you want to implement intended state is an independent thing, and so it's just kind of creating a reference anchor to basically say that's what the intended state is part of. It's not part of what we're discussing per se.
I'm only thinking from the readability point of view.
Yeah.
I don't disagree on the content, but from the readability point of view, it doesn't help.
Okay.
Maybe
Yeah.
just explaining this in words might be more useful rather than every instance of LSPDB now being called PC report
Sure.
LSPDB. And
Yeah. Okay.
yeah,
we
just
can,
think about
we
something.
can definitely take a look at trying to prune that out and simplify it then. Yeah.
Thank you.
Got the next slide, I think, actually. So presenting again, just like Samuel, my name has not changed. Presenting on behalf of the co-authors. So this is the stateful amendment. So this draft was forked from the operational document. And really there's 2 kind of optimizations that are happening in it. One is this concept of stateful turnup. And the general idea is stateful bring up, turn up, interchangeable words. Basically you skip PC request. So rather than do a PC request, reply, report, you can just say, hey, PC, here's my LSP, it's reported, it's delegated as down, deal with it when you have a chance, right? And then it's up to PC whenever it has the capability to actually send a PC update to bring it up. So you save a little bit of messaging, and you also save that overhead of sending a PC request and you don't know when you're going to get it back, right? When you get a reply back. And as well, because of the whole stateless PC versus stateful PC, it really kind of simplifies that gray area between when you transition from stateless to stateful. So it's really an optimization on the protocol itself. And then the second part of it is for segment routed paths for SR MPLS and SRv6. PCEP has the concept of ERO and RO, right? Recorded route object. There's not really a recorded route object when it comes to SR. And so the text basically says, look, for segment routed paths, you can just use ERO. You don't need to actually carry the RO. So similar to the other document, a bunch of editorial language updates, because again, these were forked from each other. Yeah, I think the main thing is it's just essentially cleaned up, refined the language a little bit. This was decoupled from the PC operational, so that way that these two drafts are not interlinked. So you will see between the two documents that there's some redundant text in there, but it's the cost of trying to keep them isolated. And yeah, same idea. There's now just some backfilling. So for example, the terminology section is missing and just a bunch of various other language changes. Same with the LSPDB concept. Yeah, so for next step, there's still some sections and gaps to fill out. When it comes to manageability and security, I'm currently drawing a blank because, and I'm sure the co-authors as well, they're also going to draw a blank because what we're really doing here is we're removing stuff from the protocol, right? You're actually saying, I'm going to drop PC requests, skip it. I'm going to drop RO, skip it. So if anybody does have ideas for those contents, like definitely reach out to us and try to get those filled in. And then, yeah, so in general, just more feedback and hopefully at some point in the adoption queue. Thanks.
Yeah, Boris, sorry, I didn't read the drafts yet, at least the latest version. So what about backward compatibility? Did you describe it already?
Yeah, there's a few sentences in there. Essentially, to have a functioning PCE, you already have situations where you need to handle a report of a down path with delegation. And so if you go and follow the stateful RFCs and implement it, if you just suddenly receive a report with a down LSP with delegation, generally those PCs already have an implementation to deal with it. So from a backwards compatibility point of view, you already have to kind of handle this. The main difference is that we're removing the requirement to say, oh, you should bootstrap it with PC request, right? So that handling logic is essentially you're already doing it. You're already kicking in. You're already handling that kind of processing. The main thing is, it'd be ideal to. It's just more performant to basically drop those PC requests for when you're going fully stateful. That is, and like I said, it removes the ambiguity about are you reserving paths or not.
Okay.
Thanks. Yeah, there's a few sentences in there. Any other questions, comments? I will disappear from here.
Thank you.
Thanks.
Next we have Samuel again. He's gone unstable.
So hi again, still myself, still same name, and still from Cisco. So this presentation is about reporting extensions in PCEP, and I'll be presenting it on behalf of authors. So our primary goal is to achieve more accurate reporting in PCEP by providing more detailed state information. So this kind of umbrella draft to cover 2 extensions right now, but we plan to add more in the future. So we are trying to make sure that we will not have to introduce more and more drafts just for, let's say, one small extension from a reporting point of view. But it is specific to reporting, so it is not describing the. It is not going into let's say update or initiate messages. So the first extension is transit eligible flag. So transit LSP is an LSP whose binding label or binding seed can be used in the path or another LSP. So to support this within PCEP, we introduced the T flag within the LSP extended flag TLV. When this flag is set, it explicitly marks an LSP as transit eligible and to make sure that the PCEP peers can handle that. We introduce the transit eligible capability as well. So if the capability is not advertised, there can be local policy to determine the flag value. So either the PC or PC can decide what is the flag value. So while the SR policy architecture defined multiple candidate part types, in PSEP there was no way to encode the information whether the part specified for the OSP is explicit or dynamic. So whether the operator specified it explicitly or it was dynamically computed either by headend or by PC. And this is impacting all the LSPs across all the part setup types, so RSVPT, SRT, SRE6, and so on. To address this, we introduced the X flag in the same TLV, so LSP extended flag TLV. And when this flag is set, it indicates that part encoded within the ERO is explicitly specified. And if the flag is cleared, it means that it was dynamically computed. And a practical use case for this is the delegation transfer for PC initiated LSPs. So when the PC initiated LSP was created via PC1, PCC will receive the path, and then that such LSP is redelegated to PC2. PC2 may not know what was the origin of that path, and it may try to recompute the path. So we are trying to avoid it, and we are trying to explicitly indicate to PC2 that the path was explicitly specified and it is not supposed to be recomputed, even if the delegation is delegate flag is set by the PCC. Now for the recent updates, originally even binding seed extensions which are presented today were part of these drafts, so we separated it since the binding seed related extensions are not really about the reporting. We renamed the E flag based on the feedback since there is conflict with PC entropy label position draft. So we renamed it to X flag. I hope that there is no other conflict which I hasn't figured out. And we clarified that both explicit and dynamic parts, so whether the X flag is set or not, can be used with the loose and strict hops as well. So either PC can compute the path with the loose hops, or the operator can specify the path with loose hops as well. And the cleanup happened in multiple sections of the document. So any comments, any discussion is welcome. Yeah, we think that the draft is prepared, so we would like to ask for the adoption as well for this one. Thank you. And any comments? Any questions?
Hello, Chen Xiong from ZT. I have two concerns about. First one is it would be better to define clearly the terminology about the transit LSP. I think it's my first time to see that word. And second is that what's the relationship? What's the difference between the explicit path and the loose path or strict path? I think that why we are defining another explicit path and a dynamic path. We have defined the loose path and the strict path in RC 5440. So that's my two concerns.
Okay, so basically for the transit eligible shred, so we can still add more details about the definition of the transit LSP. So that's great feedback. So we can definitely expand the definition. For the new flag about the explicit part or dynamic, so the strict or loose hops are the flags for the hop itself. So for the single hop in the segment list or in the pod itself. So basically the single pod can have mix of strict hops and loose hops. So even if, for example, operator define the path explicitly, they can include the loose hops explicitly. So what we are saying here is just the indication whether the path was computed dynamically, so complete path, or whether it was explicitly defined by the operator. So even when the PC is doing the path computation, it can still compute the path with the loose hops. even if it was dynamically computed. So it can be mixed. So let's say first hop can be strict, but the second one can be loose. So the path computed can say move to next node, but then I don't care what is the mid node, but I want to reach to the destination.
Thanks, Samuel. Samuel, I suggest adding this as an example in the document, and that will clear up this confusion. Because even when we discussed last time, I think this comment came about strict and loose, and you, in fact, added the text in the document. Maybe an example would be the next step to make it more extra clear with different examples. Thanks.
Thanks.
Yeah, sure. I can do that. Thanks for the questions and thanks for the comments.
Faster. Right there.
My name is Pawan Biram. I'll be introducing our draft on PCEP extensions for multipath traffic engineered DAG tunnels. I'm presenting this on behalf of the authors listed on the slide. Kiriti and Andrew are my co-authors. The notion of a multipath traffic engineered DAG, or MPTED as we call it, is discussed in detail in draft compiler that's specified on the slide. For those of you who haven't been following the discussion on MPTE and haven't attended the TEAS working group sessions and the side meetings that happen in this meeting as well as in the previous meeting, an MPTED tunnel is a T construct that contains a constrained set of paths representing a DAG from one set of ingresses to a set of egresses. When an MPTED tunnel is originated and a DAG for it is computed, the computer DAG is broken down into a set of junctions. And what we are referring to as an MPTED junction is quite simply the state associated with the MPTED tunnel that's provisioned at each junction. This state typically consists of the bandwidth that's coming in and going out of the junction. It consists of the previous set of previous hops. It consists of the set of next hops and the relative load shares with which incoming traffic is load balanced unequally at every junction that makes up the DAG. In this reference DAG that's illustrated here, we have an MPTED tunnel with a couple of ingresses, a couple of egresses. There's 12 gig of bandwidth reserved on the DAG. So to provision this MPTED tunnel, you would end up provisioning the junction state on the 10 junctions that are illustrated here for the DAG, including the endpoints. We have an RSVP document targeted for the TEAS working group, which talks about realizing the MPTED tunnel using RSVP. There is a Yang model document also targeted for TEAS, which talks about, which can be leveraged to use any of your favorite APIs to instantiate the MPTED tunnel. And this document, the PCEP document, is what we have put together to bring up an MPTED tunnel using in a PCE-based environment. So the extensions that we are going for in this document are extensions that would enable a PCC to delegate control of an MPTED tunnel to the PCE. It should facilitate the notion of a PCE-initiated MPTED tunnel, and it should also allow the PCE to act as a signaling source and basically take on the onus of signaling and maintaining the junction states. Depending on where the tunnel originator, the signaling source, and the DAC computer specific functions are located, the 4 different modes of operation that come into play when a PCE is used. In this first mode of operation, the tunnel is originated on the PCC. The signaling source is also the PCC, and the DAC computation is offloaded onto the PCE. This is something that would typically come into play if you're, for example, if you're using an MPLS forwarding plane with signal label switching and you're using RSVP to bring up your junction states. In this mode of operation, the tunnel is originated on the PCC. The other 2 functions sit on the PCE. The third mode of operation is where the tunnel is originated on the PCC, but the DAC computation as well as the junction signaling is done on the PCE. So if you see both the stateful PCE control procedures as well as the junction processing procedures are via PCEP. This is example use of this would be an SR deployment where you're using static labels. And in the final mode of operation, all the functions sit on the PCE itself. In the next version, we intend to furnish the protocol procedures for the items that are listed here. In the meantime, if you are interested in this work and if you have any feedback for us, please reach out to the authors and we'll be quite happy to chat with you.
Any questions? None? Thank you. Thanks for presenting. Sean, topology filter.
Hello everyone, this is Chuan from DT. I'm going to talk about the PCE extensions for topology filter. This document has been presented in last meeting, and we got some comments and from the meeting and on the mailing list. Thank you for the comments from Dhruv, Andrew, Dafa, and Samu. And we have revised the versions and hope that can address the concern from the new updates. For example, the IGP domain identifier has been split into optional TLVs, and we made some clarifications to clarify that how to use the TLVs to identify the IGP domain. And the existing algorithm ID TLV, as that just mentioned, and the domain ID TLV are reused in topology filter as Dhruv suggested. And the T topology identifier has been also split into optional TLV, and the clarification of the three IDs has been added in this new version. So this document proposed the topology filter object. The new object has been split in the new object will carry optional TLVs. For example, we have proposed for optional TLVs to identify the IGP domain. In last version, we have put them in the one separate TLV, and then to clarify the identifier, and they may be carried for one or two or all of them to identify an IGP domain. So we split them into several TLVs. For example, the protocol ID TLV, multiple topology ID TLV, and we also use the algorithm ID and the domain ID. They are they have been defined in other drafts. So for the IGP domain identifier, we just proposed the protocol ID and the multi-topology ID. And for T topology identifier, we also separate them into provider ID TLV and the client ID TLV and topology ID TLV. And there are no change to the filtering rule TLV. So this is the new TLVs for IGP domain identifier. We separate into several TLVs. Most important, we have made clarification how to use the TLVs. For example, the protocol ID TLV is mandatory to identify an IGP domain, and the other TLVs may be optional to carry the additional information to identify the IGP domain. And the TLVs may be carried for each type, and but only be to be presented once. And they must be applied to filter the resources. So this is the clarification for how to use them. And this is the same with the T topology identifier. There are three optional TLVs to identify the T topology. The usage is the same with the IGP domain identifier. There are no change with the filtering rules TLV. So let's recap. So if the authors would like to ask adoption, if you are you think that the comments has all been be resolved and is stable for adoption. So
Yeah, thank you for taking care of all the comments from last time. Are there
Yeah.
any questions? And otherwise, we are over time anyway. Okay, thanks.
Thank you.
Next presentation. Shoyan, SAP 4.2.
Good morning, everyone. It's Xueyan from ZT. Okay, I'm presenting the PCEP for source address validation on behalf of the co-authors. So first question is about what is SAV? SAV is source address validation. It's a security mechanism used for mitigation of IPv4 or IPv6 source address spoofing attacks by validating the source address prefix against their ingress interfaces. The CellNet working group is working on this topic. The second question is about why anti-PCE. Because CellNet architecture has two modes. One is distributed architecture, and second one is centralized architecture. And the main difference between these architectures is that who is responsible for the self-specification information collection and responsible for the management and communication of the cell information. And it's also related to about the cell rule or cell policy generation and deliver the cell policies. For the centralized mechanism, because PCE can provide a centralized architecture, and if PCE acted as a cell controller, it can provide the global visibility of the cell policy, and it can also, provide improved optimization of cell policy and provides coordination of the policies across domains. There are some potential solutions about the centralized mechanism, BGPRS as our policy, and the PCE actually is best place to address this question from our perspective. And how to achieve, through PCEP protocol to support the source address validation. It may involve, using PCEP to achieve the information collection and construct the cell policies, and then, it may also involve the delivery between the controller to the PCC. There's other things may involve, there may some network updates or some new threads coming to the network. It may also involve the updates to the sub policies. And the potential PCEP requirements, when PCE and acting as the cell controller, the PCE speakers needs to support the self-specific information collection, sub capability advertisement, and the sub policy dynamic updates and backward compatibility, and the PCEP sessions must be secured. And the information is expected to be carried. We will use the reference, from the CellNet working group draft, which defines the general cell capabilities be carried through the protocol to realize the cell validation. And how to carry the information. Actually, we propose to use stateful PCP protocol, a new flag for source address validation support is needed, and yeah, object class and the TLV format is showed at this. The question to the working group is that, is this the right place to address this question? And the second question is about, is this a right way to use the stateful PCP to support the source address validation and some other missing? Yeah, okay, thank you.
Thanks for presenting, and you are asking the right set of questions. Let's discuss these questions on the mailing list. There are some chat comments as well. Let's continue to discuss. Thank you.
Okay, thank you.
Hello everyone, this is Luis from Telefonica. I will present this draft, an update of this draft on path computation based on precision availability metrics. So a recap of the intention of the draft. So here the basic point is that some services will require let's say, satisfy SLO, service level objectives that could be described in terms of precision availability metrics. So basically statistical behavior of the metrics. So not just a single metric, but basically metrics that could be expressed in terms of histograms or a statistical distribution. This could be the case of services like deterministic services, network slices, and so on and so forth. So basically what we are proposing here is a new metric so that we can handle those precision metrics for the path computation. The draft was already presented several times here in PCE and has been already presented to IPPM. We have incorporated the comments from both working groups, and also today it will be presented to DEDNet just to collect feedback also from that community. So changes in this version, there were some comments about how to handle all these precision metrics. It could be represent a burden for the PCE. So what we propose in this new version is basically that the traffic engineering database is the one collecting the metrics and creating this statistical distribution of them, so that the PCE basically check against the traffic engineering database and basically identify the proper path to satisfy this, the precision metrics. So that basically the lifetime of the behavior around the time somehow satisfy those precision metrics. Second point was about the clarification between the interworking between the precision metric object and the metric object. We have added as well some clarification on this respect. Basically, if there are some inconsistencies, what would be expected is that the PCE will send back a PCE error message. So highlighting an invalid operation and basically reporting error values. And the final point here was to improve the description for security and operational considerations. We also added some IANA requests for these error messages. So next steps, our idea is to keep collecting comments and feedback. In this case, as I said, today we will present in DEDNet as well. So basically we try to ensure alignment with all those communities expressing services in terms of SLOs, collect more comments here as well from PCE, and preparing a new version, and in case that there is somehow we satisfy all the comments, ask for adoption in next IETF if possible.
Yeah, thanks for taking comments from the last time and updating the document. The part which is still not clear, at least to me, and maybe I need to discuss this with you more offline, is how to take those metrics into consideration when I'm doing path computation. We have described the metrics, what they mean, but when I'm computing it, and via maybe taking an example, and how would I track this over time series that you have explained?
Okay.
My question is, if I don't know the path in advance, how am I going to compute and maintain that histogram that we talked about? It's more about implementing what you have described. How do I implement it? I was not 100% sure. So I want to get some more information from you, and that could be input for the other implementers out there as well.
Okay,
thanks.
Got it. Thank you.
Next presentation is quick. remote present.
Hello, can you hear me?
Yes, please go ahead.
Yeah, this is Fuyang from China Mobile. On behalf of the co-author from H3C, the proposal is PCAP over quick. So actually, the proposal was presented at IETF 121 meeting, where many discussions focus on why PCAP over quick is needed. We have summarized some key reasons as follows. First, the security. It is easy to understand compared to PCAP over TCP. PCAP over quick enables encryption during the transmission, allowing the secure in-band communication even over the internet. The second is service migration. PCAP is long-lived and stateful session using quick avoid the interruption interrupting existing PCAP sessions when your ability is turned on. So that ensures the continuity. Third, eliminate crosstalk when consider the head of line blocking when multiple types of data share a single TCP connection. Head of line blocking can occur with quick. Different message type can be separated. For example, the keep live and open message can be isolated from the tunnel related state data, reducing mutual inference. The last one is to enable simultaneously receive and send operation. So in this draft, we have several updates. First is to update the channels. We define the control and data plane data channels. Keep live and open messages are transmitted over the control channel, which corresponds to a quick connection ID. Other messages are carried over the data channel, which can be further grouped into subchannels for PCC. For example, PCC receive, PCC send, and PCE receive and PCE send. Additionally, messages are classified by contents can be classified by content into RSVP, SRMPS, or SRv6 categories. So here, the state machine is keep the same with last version. We only we introduced 2 events just upon the something happened with quick. So that's all. Any of the comments are welcome. We will consider it, and if this is possible to improve the documents.
Are there any questions? My one suggestion would be keep discussing with other authors who are working on the similar problem. There are multiple drafts, netconf over quick, BGP over quick, BMP. So it's important that we learn from each other and use it. I have further comments that I will send to you offline. Thank you for working on this.
Yeah, thank you.
Folks, there were lots of questions last time it was presented about the need. So authors have updated the document, and even in this presentation, they have given some motivation. If you disagree with them, please reach out and let's have a discussion. We have at least one question very quickly, Andrew.
Yeah, about the need. So thanks for updating it and taking all those into considerations. The changes and the benefits, like the migration example. I mean, even if you migrate to SRv6, your MPLS is still running two PCAP channels long lived just seems heavy compared to just bounce the session and bring it online. And then the head of line blocking with keep alives, I'm not aware of most implementations having any concern with that, so I'm not sure how much you really gain. And open messages happen once.
And even the security part, PCAP is one actually supports TLS 1.3 and other things as well.
Yeah,
so even that security part is little bit.
So it's definitely like, thanks for cleaning it up. It's just I still debate the value.
Yeah,
that's all. Thanks.
Thank you. Very quickly.
Thanks. I'm Wang from Trend Telecom.
And I will introduce our draft about PSAP procedures and extension for VLAN traffic forwarding and some essential updates.
Clicker. Oh, sorry, just one second. Yes, go ahead.
Okay. The background is RFC 821 describes an architecture for providing traffic engineering in a native IP network by using the PSAP mechanism. And RFC 9050 specifies the procedures and PSAP extension for PCE-CC to derive MPLS label switch paths. So we have proposed our draft about the PSAP extension for native IP networks procedures. It can be summarized as building multiple BGP sessions between edge routers via PSAP and advertises the different prefix via different BGP sessions and steer the traffic towards the particular route via BGP next hop. So based on the large-scale development of PCE architecture and Ethernet internet interface in the native IP network, the VLAN tag is usually located in the Ethernet header. So we have proposed our draft about the end-to-end VLAN-based traffic assurance under PCE as the central controller architecture. Yeah. And as shown in this figure, the achieved requirements can be summarized as the fifth point. The first one is the same solution for native IPv4 and IPv6 traffic. And the second one is support for intra and inter-domain. And we can achieve end-to-end traffic assurance with determined queues behavior and based on the centralized controls through a distributed network control plane. And the ability to adjust the optimal path upon the changes of the path. And we can see in this figure, it points out the procedures for VLAN-based traffic forwarding. And the first step is the PCE calculates the explicit route and sends the route information to the PCC through the PC init messages. And then the ingress PCC forms a VLAN forwarding routing table, VFR for short. And the transit and the egress PCC forms a VCR table. And then the packet will be to be guaranteed will be matches the table and then be labeled with corresponding tag. Label packet then will be transferred along the path of the VSP. And this figure shows the data packet encapsulation process. And because time is tough, so we can go briefly. And we're including the VLAN information into optimal paths calculation and provisioning by central controller. The overall queues can be achieved. And the advantage of this mechanism, it is use a completely new address space to bypass the already used MPLS label space, can fully utilize the existing PCE architecture and avoid the SRVD V6 SRH overhead problem. And this figure shows, corresponding to the previous slides, this picture shows the PCE init VSP info definition. We made some definition and in our draft. And we have updated some contents, but it integrate the data plane operation for VLAN switching into appendix to better focus on the protocol or format scope on the IETF. It describes the structure of VLAN forwarding and VLAN crossing routing table, describe VLAN-based traffic switching process in detail. So since we are currently in the work group adoption queue, so most solution and comms are welcome. Please follow me by email. Thanks. Any questions?
Yeah, thanks, folks. We are over time, so please give your feedback. If you like this idea, if you hate this idea, whatever you have, let's have the discussion on the mailing list. We haven't got feedback on this draft much, and authors have presented this before. So if you have concerns on this, please use the mailing list and have a good rest of the day. Thank you. And apologies for going a few minutes over.
Bye. See you in Montreal.